You ever wonder what would happen if we could teach an AI to be, well, curious? Not just to follow a list of commands, but to actually explore, to try things out, and to learn from its own mistakes, just like a person does. Well, let's get right into it, because some new research proposes a framework that does exactly that. It's this weird paradox, right? An AI can master an incredibly complex game or write flawless code, but then it gets completely hung up on a simple task that just needs a little bit of trial and error. So what gives? Why are these super powerful agents so rigid sometimes? That's the big question we're digging into today. The heart of the issue is something researchers call AI's exploration problem. And yeah, it's a fundamental challenge that this new research is designed to solve. Okay, so this slide really breaks down the core dilemma that every AI agent has to deal with. On one side, you've got exploitation. That's just sticking to the moves it already knows will probably work. But on the other side, you have exploration, trying out new, totally random stuff in the hopes of stumbling on a way better solution. If you lean too hard on exploitation, the AI never learns anything new. But if you lean too hard on exploration, it just messes around and never actually solves the problem. Finding that sweet spot, that's the holy grail. And listen, this isn't just some abstract idea. The researchers behind this new framework, they put it really bluntly. Our current methods, especially reinforcement learning, or RL, tend to create AIs that are great at exploitation, that just awful at exploration. They get really good at doing one thing, one way, and then they just fall apart when the situation changes. So if the old way of teaching AIs isn't cutting it, what's the answer? Well, it's a meta solution. It's about a shift in thinking. We stop trying to teach an AI what to learn for just one task, and instead we start teaching it how to learn, period. Think of standard reinforcement learning, or RL, like you're cramming for a single test. The AI basically memorizes all the answers and strategies it needs to get the highest possible score on that one specific test. It works, for sure, but that knowledge isn't really flexible. But meta reinforcement learning, or meta RL, that's a whole different ballgame. This is like actually learning the subject. The goal isn't just to ace one test, it's to understand the core principles so you can solve any problem in that subject. The AI learns the strategy of learning itself. That's the key. It learns how to adapt. And all of this brings us to the star of the show today. Let's meet Lammer. It's the specific framework from the research paper that puts this really powerful meta-RL concept into practice. So what is Lammer exactly? In a nutshell, it's a system designed to train large language model agents to do what we've been talking about this whole time, to get out there, actively explore, and, this is the most important part, to actually learn something from every single attempt, whether it works or not. Now, the secret sauce for Lammer really comes down to this two-step process. First up is cross-episode training. Instead of treating every try to problem like a totally new game, it connects them all together, so the AI starts to think about the long game. And second, and this is just brilliant, is in-context reflection. After a failed attempt, the AI literally stops, thinks about what went wrong, and then writes itself a better game plan for the next try. How cool is that? This slide just lays it out so perfectly. Look at the top there. That's your standard RL. It's just a bunch of separate shots in the dark, hoping one of them hits the target. Now look at the bottom. That's Lammer's approach. The attempts are sequential. The first try informs the second try, which informs the third. Every failure becomes a stepping stone, not just a dead end. Okay, the theory is awesome, but, does it actually work in practice? Let's get to the good stuff, the results. Let's see the proof. And wow, the results are pretty darn compelling. This table pits Lammer against the best of the best in traditional RL methods. We're going to zero in on that pass at 3 column. That's the success rate after just 3 attempts. Let's see how much of a difference this new approach really makes. In the classic puzzle game Sokoban, we're talking an 11% improvement over the next best model. That's not just a little bump, that's a really solid jump. But then you move over to the logic game Minesweeper, which needs some serious reasoning, and that leap gets even bigger. We're talking a 14% gain. And then, get this, in the super complex web shop simulation, Lammer just blows it out of the water with an incredible 19% higher success rate. This shows its adaptive learning isn't just for simple games. It works in messy, realistic environments too. So what's really cool is how Lammer is winning. This chart shows something called trajectory diversity, which is really just a fancy way of asking how creative or varied are the AI's attempts.
So your base model is all over the place, super creative, but fails a lot. Standard RL is the opposite, not very creative, but a bit more successful. But look at Lamer. It's the best of both worlds. It maintains that high creativity and gets the high success rate. It explores like a champ and it wins. But here's the real game changer. Lammer isn't just better at the stuff it was trained on. Because it actually learned how to learn, it can take that skill and apply it to brand new, much harder problems that it's never ever seen before.
And this table right here is the proof. The researchers threw tasks at these models that they were explicitly not trained for. And while the standard RL model did okay, Lamer didn't just do okay, it totally dominated. Look at that cool task, a massive 23% performance gain. This is what true flexible learning looks like.
So what's the big picture here? What does all this really mean? Well, this research is pointing us toward a future where AI agents are way more adaptive, way more autonomous.
All right, let's just quickly recap the big ideas. Meta-RL is a total paradigm shift. It teaches AI as the actual skill of learning. The Lammer framework puts that into practice using cross-episode training and self-reflection. And the result? You get an AI that not only performs better on its homework, but can also ace surprise quizzes on stuff it's never seen. This is a huge step toward AIs that can actually function out there in the messy, unpredictable real world. And that leaves us with this one last kind of mind-blowing thought. For so long, we've been giving AIs a destination. Now, we're giving them a compass and teaching them how to explore for themselves. So if an AI can truly learn to be curious, to explore on its own terms, what new solutions, what new ideas, what new worlds will it discover for us?